right, let's take a look at Chapter 22, Exercise 9. Spinning Euros. All Euros have a national image on the head side and a common design on the tail side. Spinning a coin, unlike tossing it, may not give heads and tails equal probabilities. Polish students spun the Belgian euro 250 times with its portly King Albert displayed on the head side. The result was 140 heads. How significant is the evidence against equal probability? Follow the four-step process as illustrated in example 22.6. The four-step process is to state, plan, solve, and conclude. If we state our plan, state our problem, then we're asking ourselves, is the proportion of spins that land as heads the same as the proportion of spins that lands as tails? Are the proportions the same? The plan is to test the null hypothesis that P is equal to P naught and against the alternative hypothesis that the proportion is not equal to P naught because we don't have a left or a right leaning. All right, so P naught here is equal probabilities. So equal probability is a 50-50 chance. Where we're letting P be the proportion of heads landing spins. So just to clarify what a win is and what a fail is, P will be the probability, or I'm sorry, the proportion of head spins. Okay, so that's also part of our plan. We can use this test if n is large enough. N is large enough if the number of wins is more than 10 and the number of fails is more than 10. If half of the 250 were heads, that would be 120, 125, and 125 fails. So n is definitely large enough. All right, so this is our plan. We need a z-score then, and that will start our solving process. So let me write our alternate and our null hypotheses, just so I have them. Not equal to 0.05, which actually means two-tailed for us. All right, so let's look at having a z-score and a p-hat, right? So p-hat is the number of heads out of the number of coin spins, and the standard error of p hat, right, is that p naught, well, I guess not the standard error of p hat, but p naught over n, so just the standard error. All right, so 140 divided by 250 yields a p hat of 0.56. So a probability of 0.56 that it lands on heads when you spin it. And the standard error is 0.5 times 0.5 actually, divided by 250 and then rooted, which is approximately 0.0316. Now, the z-score is p hat minus p naught divided by that standard error, which is 0.56 minus 0.50, where p naught is 0.50, divided by 0.0316. 0.06 divided by 0.0316 is 1.89, and then something that makes us round up the 9, so 1.90 when we round. So we have a z-score of 1.90. And what else do we need? We are trying to do a two-sided test, right? Two-sided test, if you recall, looks like a critical region on each side of absolute value of z. And what we're looking for now is a p-value, not the proportion, but our p-value. Here in the two-tail, that's 2 times the proportion that a z is greater than the 190 that we got, our z statistic of 190. Using our book, we find that value to be 0.0287 times 2 gives us a p-value of 0.0574. And now we're asked, how significant is this evidence against equal probabilities? Well, if this were, say, we haven't gotten into it, but even at like a 95% confidence level, for example, alpha would be 5%. And we have a p-value of 5.74%. So although we would not reject the null hypothesis, it's very close. So possibly if we ran more samples, more spins, right? If we did more and more spins, we might have a more conclusive answer. So our conclusion is that there is some evidence. So step 4, conclude. There is some evidence that the proportion of times the Belgian euro coin spins heads is not 0.50. So there is some evidence, weak, that the proportion of head spins is not 0.50. So there's some evidence. It's weak, but it's there.